Hi everyone. Now we are going to discuss on the analysis of the half-wave control rectifier with RL load and freewheeling diode. So basically there are two modes of operation are there, and the first one is known as the conduction mode and the second one is the freewheeling mode. So conduction mode is basically from alpha to pi, that is from this region. So this is the region for alpha to pi, that is the conduction mode, and it again repeats at 2 pi plus alpha to 3 pi. And the freewheeling mode is basically from pi to 2 pi plus alpha, and again repeating at 3 pi to 4 pi plus alpha. So our intention is to find out the equation for your current during these two conduction periods. So in the conduction mode, we can write it as Vm sin omega t is equal to R I naught plus L into d I naught divided by dt. And in that you will be having the current can be solved as in the earlier case. So the total current I naught is nothing but the sum of your steady state component plus your transient component. So this part is nothing but, so you can write it as I naught as Is plus It. So this is nothing but your steady state component, and this is nothing but your transient component. So now we need to solve for this. In order to find out the value of A, we have to put the boundary conditions, and therefore we need to find out at the value of omega t equal to alpha. At omega t is equal to alpha, what is your I naught? So again you can take. So you can see that the current waveform is basically moving like this, and then again moving like this. So you need to define the value of current at alpha and also at phi. So for that purpose, so I have defined it here as I naught is equal to capital I naught at omega t is equal to alpha, and similarly at pi I have mentioned I naught is equal to capital I naught 1. So at omega t equal to alpha, your I naught is nothing but capital I naught, and therefore you can write out the value of I naught is equal to Vm by Z into sin omega t is nothing but alpha, so it is sin alpha minus phi plus by omega. So from there you can find out the value of A, which is equal to I naught minus Vm by Z into sin alpha minus phi into e raised to R alpha by L omega. So therefore you can write your value of I naught as, substituting the value of capital A in the above equation, you can write I naught is equal to Vm by Z sin of omega t minus phi plus e raised to minus raised to. So this is your equation for your current I naught from the period of omega t is equal to alpha to omega t is equal to pi. Now we are going to discuss on the freewheeling mode of conduction. So that is from pi to 2 pi plus alpha, and also again repeating as 3 pi to 4 pi plus alpha. So we have already defined at pi your current I0 is nothing but I01, and during the freewheeling period there is no connection with the input supply source, and therefore the current is freewheeling through R, L and through the freewheeling diode, and therefore you can write your voltage equation as 0 is equal to, because your input voltage is 0, R I0 plus L into d I0 divided by dt. So you can solve it for the current. I0 is nothing but a e raised to minus r by L into t. So at omega t is equal to pi, your I0 is nothing but I01, and therefore I can write A is nothing but I01 into e raised to r pi divided by omega L. So therefore I0 is nothing but I01 into e raised to minus r by L into t minus pi by omega. So this is for the period from pi to 2 pi plus alpha, and you can also find out your average output voltage. V0 is equal to 1 by 2 pi, because 2 pi is 2 time period, and the output voltage is available only from alpha and then to pi. So it is from alpha to pi Vm sin omega t d omega t. So you will be getting your answer as Vm by 2 pi into 1 plus cos alpha. Similarly, your average load current I0 is nothing but V0 by R. Now we are going to compare the power which is consumed by a half-wave control rectifier with R load without freewheeling diode and with the freewheeling diode. So here you can observe that from alpha to pi, your voltage and current both are positive. From pi to beta, your voltage is negative and your current I is positive. So from alpha to pi, the inductance is storing the charge, and from pi to beta, whatever the energy stored in the inductance L is being returned to the source as another power. So the net power which is consumed by the load is different, because during this particular stage the inductance is storing energy, and during this stage the inductance is releasing the energy. So it is giving back to supply, and therefore the total power consumed will be different. Now we will see our explanation with your RL load with the freewheeling diode. In that particular case, you can see that from alpha to pi, your voltage and current both are positive, and therefore the inductance will be storing the charge. And from pi to 2 pi plus alpha, the energy stored in the inductance L is being delivered to your resistance R. So through the freewheeling action. So here we can draw it. You have your resistive load, you have your inductor, and then you have your freewheeling diode. So from alpha to pi, the current flow is like this from your source, and from pi to 2 pi plus alpha, whatever the energy which is stored in the inductance is being returned through the freewheeling diode to the resistance R. So therefore, the total power which is consumed by the load will be more in the case of a RL load with the freewheeling diode when compared to an RL without freewheeling diode. And also you can also note down the input power factor. So your input power factor is nothing but power delivered to the load divided by input volt ampere. And therefore, with the use of the freewheeling diode, the power factor is much more improved. So the advantages of using the freewheeling diode are the load current waveform is improved and the input power factor is improved, load performance gets better, and the energy which is stored in the inductance is transferred to resistance R during the freewheeling period, and therefore your overall converter efficiency improves. And one of the disadvantage with this kind of systems with the freewheeling diode is that the supply current IS, which is taken from the source, is unidirectional and is in the form of a DC pulses. So in the case of single phase half-wave converter, introduces a DC component into the supply line. So that is with our discussion with your RL load with and without freewheeling diode. Thank you.